Okay, hello everyone. I'm Kamna Mishra from IIT Mandi, and this is week 11 of Probability and Statistics Problem Solving Session. So, the instructor of this course is Professor Somesh Kumar from IIT Kharagpur. So, today's class is basically based on the hypothesis testing. Okay. So, in statistics, this is we use hypothesis testing in many real life problems also. And basically, the main use of doing this is that we perform any kind of test, or we check, let's say, for the mean, whether the mean of sample or population is same. So basically, when you have, let's say, a population, let's say the population of India, and then you want to see, let's say, if you have population of India and then you want to say some percentage in any field, then it's very tough to go through each and every person of the India. Let's say, how do we find the literacy rate? So we just do not go to each and every person and then ask for whether you have this much knowledge or not, or something like that. So what we do is that we take a sample. Now, on depending on the uh, sample size and different kind of samples, like whether we are doing the random sampling, whether we are doing some stratified sampling, which way we are sampling this, right? It matters a lot, because otherwise what will happen if we have, we have uh, let's say we are choosing the people of uh, Delhi, and then we are asking the students of Delhi University only about the education. Then we are missing the other people, right? So when we are missing, then this is not a random sampling. We have chosen our sample from a very specified area, so we cannot say anything about the literacy rate in Delhi, because what will happen, even if we will say, that it will have very much error. Okay, so this error is depends, like whether it is acceptable or whether it should be rejected. So now it is very important how we do the sampling, and depending on that, once we have done our sampling in a very good way, in a good way means in a way that it will basically a random sample, taken, not taken from a particular area or background of people. So after that, we do the hypothesis whether it's this random sample have the properties of the whole population or not. That means, if, if whether it's mean or it's an average, on an average, whether it is true or not. So let's say, uh, I'm saying that I have taken some random sample of, uh, let's say, 10,000 people of Delhi, and then I'm saying that literacy rate is, like, let's say, 760. Okay, 7,600 people are educated, like the basic education they have. Then what will I say is that the literacy rate is 76%, right? And then we will think, means we will do some hypothesis testing whether the whole population have this literacy rate or not. So this is very important, hypothesis testing. And then we have some error in that, like we say 5% or 10%. So I'm gonna give one example. So this is where I use hypothesis testing and all. So what happens is that, firstly, we have hypothesis H naught, and then this one is alternate hypothesis. So this is called null hypothesis, and this one is called alternate hypothesis. Okay. Right? Now, null hypothesis and alternate hypothesis, right? So let's say I have a data, okay, and I say that this data, let's say I have done some test in Python or in R, we basically do, or MATLAB, uh, any software, and I have said that this data follows normal distribution, okay, under the significance level 95%. Now, what does this means basically in real life? So, let's say you have a null hypothesis is that whether the data follows normal distribution or not. Right? Now, alternate hypothesis will be what? This will be the opposite of this. Okay. So, if you have now this is basically if you have, let's say, the mean life of bulb, let's say if you are saying it's 5.2. Now h1 can be, what can happen is that this may happen, or if you have h naught 5, say mu is equal to 5.2, your alternate hypothesis can be this, or it can be h naught h1 mu is equal to 5.2 and mu not equal to 5.2. Okay. So now there are three alternate hypotheses. Okay. So what happens is that you take one hypothesis. So I'm just saying that the life of a bulb I'm using, so its mean life is 5.2 years. Okay. So what can happen is that, or maybe let's say if a company makes like hundred of or thousands of bulb, and I'm in general, and that company in general says that the mean life is what it's 5.2. Okay. So what will happen is that, let's if you have 1,000 sample, then on basis of that sample we will say what is the mean life, right? So the alternate hypothesis can be the mean life is less than 5.2, or it may happen is that mean life is greater than 5.2, or what can happen is that the mean life is not equal to 5.2. So what happens is that these two are called one tail test, and this is called two tail test. Now, why we call it one tail or two tail? This is very obvious thing, because here we are checking just the left tail, and here we are checking the right tail, and at this part we are checking like this mean is 5.2, less than or greater than anything, then it will be um, alternate hypothesis, right? So this is basically mean by uh, tail test, which tail test we are using. So till now we know that what is null hypothesis and then what is alternate hypothesis. Now the next thing is that significance level. Significance level, right? So let's say I say 95% significance level, right? 95% significance level means if it comes under the 95%, then it is significant, otherwise it is insignificant. Insignificant means, let's say, my data is following the mean normal distribution. So now I will say whether it is following it is significantly or insignificantly, right? So at that point, we use some KS test called Mugarovich-Neuro test. So there are different tests for that, which we are not dealing with now. That is different, but that is significance, meaning whether it is because, let's say, if you have any data, then it will not be like this, right? If you have any general data, if you have any real data, it is not like this. Okay, it will be something like this. Let's say this and this. Let's say this, right? So its density will be a little bit different. It is not possible that it will have exact normal distribution, but then it should not be like this, right? So this and this can be similar, but this is very different. So what happens is that if you, that's where we say 95% significance means we allow 5% of error. That what it means. Okay. So if we, there is need to allow some error. Otherwise, if you perform the test without any error, then that means then you want exactly this fit, and this fit is very rare. Then it will be very difficult. So what we do is that we say, okay, we are allowing this much percent of error, and then why do we allow this error? Because once we know that our data is following this particular distribution, then we can find the future projections, right? Another thing is that in the time of seeing the trends in the data, so in the time of seeing the trend analysis, then also it happens that whether it is increasing significantly or it is just increasing, right? So what happens is that sometimes you have increment like this, and sometimes you have, let's say, sorry, you have, let's say, this is the baseline and you have increment like this. Then you need to check whether this is significant increase or not. Okay, otherwise what will happen is that if it is not significant increase, then it may like end up very constant, and then your projections will be different in the future, right? So it is very important to understand why we use the significance level. So the more you increase it, let's say I'm taking it rather than 90, I'm taking it 99%. So I'm making my things more clear. Okay. So at that point, I'm just being more rigid towards my result, that if it is not doing best like 99%, then I'm not considering the that it as trend or fit or anything. Like, I'm not considering that my sample is good enough for my population. So, and if we take 90%, then we are just align the error more. So what we are doing is that, okay, if there is 10% error in the sample, then also we are accepting this sample, and then on the basis of this sample, we can predict about our population, right? So that is the error present. Okay. Now there can be two types of hypothesis also. So first one is that simple simple hypothesis, and the next one will be a composite hypothesis. So let's say if we have a hypothesis that whether a data is satisfying the some distribution, or whether we are saying that whether this will happen, then we are then just accepting the hypothesis, otherwise we are rejecting the hypothesis. This is simple hypothesis. Composite one means we are just okay. So simple one, let's say we have this hypothesis testing whether, let's say, h naught is 5 and h1 is mu is equal to mu not equal to 5, right? So this is simple hypothesis. So uh, that means if mu is 5, we will accept the hypothesis, otherwise we will reject the null hypothesis. Now the composite one is what? Composite one is h naught, let's say mu is equal to 5 and h1 is mu is equal to 6. So there is nothing in between. So this will be a little bit complex, because if the hypothesis, because it may happen that mean is neither mean is neither 5 nor 6. So this is checking this hypothesis will be a little bit simpler, but the composite one is that either mean is 5 or 6. So there can be maybe we need to allow a lot more error in this, or otherwise we need to be very 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 specific about the things, right? So these are just, and the next thing is that this one is simple, this one is composite, and the uh, simple one is also the thing that when we give the whole information, right? So if we are just specifying the whole thing, then it's simple. So here we have, just let's say we have normal distribution, and then we are specifying only mu. We are not saying anything about the variance. So what will happen is that we can say the variance, like it may happen we have a data with 100, let's say n is equal to 100. Okay, so if we have sample size of 100, and as we say is that mean is same as this, sorry, mean of the sample is same as the mean of population. So what will happen is that this will be 5, right, according to null, and this will be 6, but the variance will be different in the both time, right? So we are not giving any kind of information, so we are not specifying the things about the whole. So this one will be composite hypothesis, and the simple one will be what, in which we will give. So this you can take in the time of let's say bulb, and this is we are saying, so in the time of, let's say, exponential distribution, where you have only one parameter, which is mean, which is lambda. So at that point of time, let's say exponential distribution, for exponential distribution, this one will be simple hypothesis, right? So for exponential, this one will be simple hypothesis. That means because we have only one parameter, so we are gonna give the information only about one parameter. But in the time of uh, normal distribution, this one will not be simple, right? This one will comes under composite, and the simple one will be we give the information about that also. Sorry, sigma is equal to 1. equal to 6 and sigma is equal to 1. So we are saying that our mean is changing, but our variance is not changing, right? So this we can say in the time of simple hypothesis. That means we are specifying the whole distribution, right? Now the next thing is uh, critical region and acceptance region, right? So there will be three types. So in one, this kind, this kind, and this kind, right? So so these are the points. Okay. After that, we say that, that this is at this point, this region is called critical region, and this one is acceptance region, right? So this one is acceptance region. So this will work in two-tailed test, right? So we are saying uh, mu is equal to 95, and then on the basis of this we will reject, right? And this is if you take alpha, right, alpha, then this will be alpha by 2 minus alpha by 2. This one will be minus alpha, this one will be plus alpha. So these are the acceptance region and these are the rejected region. So this part, a point after which and before and after, and here just before, here after. So these are the points denoting the critical region. So if the value goes after that, then it will lie under the rejection region, right? So this is basically acceptance and rejection reason. Now there are errors. So any hypothesis we do, as I told you earlier, we need to allow some error. Otherwise, what will happen is that we will have a lot of data, but we will not be able to get any kind of information from that data, because the real data we generally do not have any, like, it may happen is that the real data is not following any kind of distribution even after allowing the error, because it is so abrupt changes are happening in that data, or maybe it is uh, not capturing well, maybe we have not captured well our data, or there may be very different reason, right? So there may be like certain things like in the signals sometimes there may happen is that we have like some changes, like some unknown changes. So at that point of time is it is different, but otherwise we have like a huge family of distribution, and then if we permit some error, then we can surely see the future, or we can surely predict the future of this particular signal, or any other time series or something like that, right? So then we have some error. So we have two types of error, which one is type 1 error and type 2 error. So basically, we denote this error by alpha and we denote this error by beta, right? So alpha is the error which happens when we reject H naught when it is And this one is that when we accept the H naught, when this. So what can happen is that let's say we have any we have, let's say, two hypotheses, let's say H naught and H1, and let's say H naught is that data follows normal distribution and H1 is data not follow normal distribution, right? Data doesn't follow distribution. So H1 is what? When we reject H naught when it's true. So what happens that our data was actually following the normal distribution, but because of this error, we have rejected this thing and we have said that it is not following. Right? Other thing is that, or like, let's say the number of accident happens in one day in Delhi. So that also can happen, that if I'm saying that number of accident happens is, let's say, 250, right? And it's around 250 or 251, 252 with some error, but then we are rejecting it because it was not exactly 250, but then on an average it is around, let's say, the first day it was 251, second day it was 249 or 248, or maybe somewhere in between, let's say 245 to 255. And then I have said it is 250, but then we have rejected H naught because it was not exactly true. So that one is type 1 error. The second one is that we accept the H naught even when it's false, right? So these are the types of error which may happen. So what and the other things are, there can be several, like several examples. So basically till now we know that that this hypothesis testing is very important, and then we we really need to do these testings to do the right conclusion, to go through the right conclusion, right? Okay. So next we are starting the questions for the today's class. So the first question is that in testing hypothesis H1 against an alternative K1. So here H1 is what? Null hypothesis, right? And K1 is what? Alternate. So K1 is our alternate hypothesis. So now probability of type 1 error. Probability of type 1 error. So what was type 1 error? That was alpha, right? So probability of alpha. So alpha, that means we accept, so that means, sorry, that means we reject the null hypothesis when it was true. So that means reject the null hypothesis in all the part when H naught is true, right? When null hypothesis is true. So this will be the answer, that reject the null hypothesis when null hypothesis was true. So this one is type 1 error. Right. So this one will be the answer. This was very, these are some are very basic questions, like just on the basis of the notes I have told you, right? So next question is that let the null hypothesis be that the alleged culprit is innocent. Okay. So firstly, you need to write what is null hypothesis, that, and then you can represent H naught, H1, K1. You can represent in any way. You just need to remember what was your null hypothesis and alternate hypothesis. Okay. So H naught is what? Culprit is innocent, right? And H1, the alternate hypothesis given here is that he or she is a criminal. So this culprit is criminal, right? So if judge wrongly pronounces means he did the wrong thing. That means there is an error, right? So wrongly pronounces alleged culprit to be a criminal when it is innocent. That means he accepted the H1. We do not say accepted an alternative hypothesis. We said that rejecting null hypothesis. So what he did is that said it's criminal. Sorry. He said it is criminal when he or she is innocent, right? So he said it's criminal when he or she was actually innocent. So that means rejected the null hypothesis when the null hypothesis was true. So we say rejected H naught when H naught is true. So what is this? This one is type 1 error, right? This one is type 1 error. This is so this one will be the now the next thing is what? Next thing is that we have a random sample. So we have x1 to xn. This is the random sample from the normal population mu comma 1, right? Now consider the hypothesis testing. Consider the hypothesis as h1 is equal to mu naught, right? And k1 is equal to mu is equal to mu naught. So whenever it is written like we are testing h1 versus k1, then you take this as null hypothesis, this one as alternate hypothesis, right? So this one is null hypothesis, this one is alternate hypothesis. So and also one more thing given here is that mu1 is greater than mu, right? So now we need to do this test at the level alpha is equal to 0.05 is to reject H1 if. That means when we can reject this null hypothesis. So when we can reject alpha is equal to 0.05, this means we are dealing with the thing so we are taking mu1 is greater than mu naught. We are not taking mu1 not equal to mu naught, right? So greater than mu naught means one test, right? So so when we are doing this one tail test, we take the z alpha uh, is equal to 1.645, right? So because we take Z alpha Z 0.05. If we take two tail test, then we take Z alpha is equal to 1.96. So first thing that means it will come in this or this. Now, when do we reject it? So we reject our null hypothesis when our Z is greater than Z alpha, right? So z is greater than z alpha, then we reject the null hypothesis. Now z is what? X bar minus mu divided by sigma divided by root n, and z alpha is what? 1.64, right? So now sigma, it is coming from n mu 1. So sigma is what? 1, right? So root n will go here. Sorry, root n will be above here. So it will be what? 1.645 divided by root n x bar minus mu, and then divided by 1 you can take. So x bar will be greater than mu plus mu plus 1.645 divided by root n. And then we are checking this as mu naught. So here we take the null hypothesis mu naught, right? So this one will be when x bar will be greater than equal to 1 point mu naught plus 1.64 divided by root n. Then we reject this null hypothesis, right? Okay, so now we want to find what is the correct statement. So before finding the correct statement, power. What is the power of test? So power of the test is power of the test is equal to 1 minus beta. That means 1 minus type 2. Power of the test is basically means how powerful our test is. So the time where it says most powerful test, MP means most powerful test. So that means how powerful our test is. So then power of the test is 1 minus type 2 error. So we can see that power of the test is directly dependent on type 2 error. So it is 1 minus. So when type 2 error uh, increases, this power of this power decreases, right? So power type 2 error decreases, then power increases. So this one is not true. Then type 1 not dependent, and then type 2 error decreases, and then power increases. So this one will be the correct answer. So if type 2 error decreases, the power of the test will increase, right? So the next question is that we have x x following the binomial distribution with n p, right? So n is the number of sample which is known, it's given here, and p is what? P is the probability of truth, right? Truth value. So now we are testing H null hypothesis. P is equal to 1 by 2, sorry, and K is equal to sorry, K is alternative hypothesis, that which is P is equal to 3 by 4. So we are saying a test is reject H if X greater than 2, right? So what is the power of test? What is given here? So this is the test. Reject H if X is greater than or equal to 2. Right? Now, there is one thing you always need to remember, that power of the test is what? Related to type 2 error. So whenever you take the power of test, you need to find the power of test. Then you will always use the p given in the alternative hypothesis. And whenever you are using this type 1 error, then you always use the p given in uh, null hypothesis, right? So here we need to find the power of the test. So power of the test will be what? X greater than or equal to 2, given the p is equal to 3 by 4. Okay, now how we have written this as power of test. So I have written this power of test like this. Now you need to know how. So beta, which is type 2 error, right? Now power of test is what? 1 minus beta, right? Beta is what? Type 2 error. Type 2 error is what? Probability of accepting H1 when H0 is true. Right? Sorry. Okay. Accepting H0. Accepting H0 when it is false. So this means, right? So accepting H when H is false. So now when we are accepting H, here we are rejecting H if X is greater than 2. So accepting H means X is less than or equal to 2, right? Given H is false. H is false means P is equal to 3 by 4. Now this will imply probability X greater than or equal to 2. P is equal to 3 by 4. So this is power of test, which I have written here. Probability of X greater than or equal to 2. Uh, sorry, here, since it is discrete, it matters very much. So X needs to be less than 2. So this is how we have found power of the test. Now power of the test, of course, we it's binomial, so we are not going to with greater than. We will just take 1 minus x less than 2. So 1 minus probability of x is equal to 0 when p is equal to 3 by 4, minus probability of x is equal to 1 when p is equal to 3 by 4, right? So 1 minus x is equal to 0, that means n c 0, and then 3 by 4 to the power 0, 1 by 4 to the power n minus nc1, 3 by 4 to the power 1, 1 by 4 to the power n minus 1. Right? So it will be what? It will be 1 minus 1 upon 4 to the power n minus 3n divided by 4 to the power n. Right? So it will be 4 to the power n, 4 to the power n minus 3 minus 1. So it is written in this form. So it will be 1 minus 1 plus 3n divided by 4 to the power. So this will be the uh, answer of this question. Next, next is that in this question also we need to find the power of test, right? So the difference here is that in the last one we were dealing with the discrete distribution, and here we are dealing with the continuous distribution. So this is the only difference. So here the difference, the distribution, you can see that this is basically the not exact we have defined till now. So this is the PDF is given, right? With the thing h naught is equal to theta upon 2, and h1 is equal to, sorry, theta is equal to 2 and theta is equal to 3. Following the test used is reject h naught if x1 is greater than or equal to 1 by 2, right? And x1 is random sample of size 1, right? So size is 1 now drawn from the above, right? So our the test. Now from here you must have understood is that if power of test is 1 minus probability accepting h naught when h naught is false, so power of the test is will be probability of rejecting h naught when h naught is false. So this will we can write as that probability of rejecting h when h naught is false. Right. So h naught is false means we are taking the theta is equal to 3. So when we are rejecting h naught, when x1 greater than or equal to half, right? And h naught is false. So h naught is false means we are taking theta is equal to 3, right? X greater than half, so we will deal with, here it is continuous, so half to infinity. Oh, sorry, x is in between 0 to 1, so 1 to infinity it will be 0, so half to 1 theta x to the power theta minus 1 dx, and theta given here is what, 3, so it will be 1 by 2 1 theta x square dx, so it will be x cubed by 3, which will be cancelled out, so x cube will remain 1 by 2 to 1, so it will be 1 minus 1 by 8, it will be 7 upon 8, right? 7 upon 8 is 7 divided by 8 is 0.875, so it is 0.875 will be the answer. Jadip, okay, if you don't have any question or doubt, then you can mute yourself, right? So we are done with this question. Now the next question is that we have a random sample of 500 registered voters in Phoenix. Uh, is asked if they favor the use of oxygenated fuels year round to reduce the air pollution or not. Now, if more than 400 people, voters responded positively, we will conclude that more than 60% of the voters favor the use of these fuels, right? So, what we are saying, if x greater than or equal to 400, then we are concluding that we will conclude that more than 60% are are in favor, right? So now what is given here is that h is equal to p is equal to zero point 0.6 and h1 is equal to p not equal to 0.6, right? So what is the type 2 error probability if uh, 75% of the voters favor this action, right? So type 2 error probability if 75% of the voter. So till now we are saying we will conclude 60% and otherwise not 60. So type 2 error, in the type 2 error what I have told you earlier, that we always take the probability which is in h1. So here we will take 0.75, right? So beta will be what? Probability of uh, x, probability of what? It is accepting h naught when it is false. So what we were accepting was 400. So it will be probability x greater than 400, and when it is false means p is equal to zero point 0.7, right? Now, since it is binomial, as you can see that p we you have given and this you have given. So x is basically following binomial 500 with zero point 0, zero point 0.6 probability. But it will be very difficult if we will deal with the binomial distribution here, right? So we will solve it by because what will happen, it will be 500, 500c 401 and then 402, and it will be a lot hectic work. So we can use the normal distribution here, right? So 12, just a minute. So it will be x minus np divided by under root npq and greater than or equal to f 400 minus np divided by under root npq, right? So at that point we have np. So because this is the mu and this is the standard deviation for the binomial one, so to normalize this x we will take this value. So np will be what? N was 500 and p was 0.75, right? So it will be 370, and then under root NPQ will be the standard deviation. So standard deviation will be what? Under root 500 times 0.75 and times 0.25, right? So its value will be, sorry, I'm just gonna use the calculator for that. So its value will be 500, sorry, 500 times 0.75 times 0.25, and it will be 9.68. So it will be 9.68. Okay, so the beta will be what? Probability, and then we can take write this as z, because now it is standardized, and here we can write 400 minus 375 divided by 9.68, right? So this value will be 400 minus 375 divided by 9.68 is approximately 2.58. So this is 2.58, 2.582 intake. Now, one now we can find this value by using 1 minus 5 of 2.582, right? So for that, we need to see the z table. Okay. 2.58, we can also see just the opposite of this, so it is 0.0049. Okay, so either we can do in this way, or we can just simply write this as minus of 5 of minus 2.582. So this one, sorry, 5 of minus 2.582, and then we have the negative table here, so we can take minus of 2.58, which is 0.0049. So this 0.0049. Do we have any question? What was that thing? Yes. Which book is best for the probability and statistic? Okay, I actually there are hundreds of books for probability and statistics. So best book I don't know, and I can't even say. But uh, if you want to have the basic knowledge along with a lot many questions, like in terms of example and exercise, then you can see Gupta and Kapoor. And otherwise, like for this exam, you can go through the lectures. This will be kind of, I think, enough. Because like in lectures, there was like huge knowledge, literally, because I have done this course 2 3 years before. But otherwise, you can take Gupta and Kapoor, because this one is the basic one. So if you want to just give it a start, because there is like every like small things are covered also, so that you can take. Okay, and otherwise you can search. So, do you have another question, ma'am? Is that score table provided? Yeah, if it will not be provided, because I have literally no idea, I've never given the exam. If it will not be provided, then you will be given the values you need to use. Otherwise, two three values you need to remember, like z at 0.05 will be depends on significance level and two-tail test. So for two-tail test, it is 1.96. For one-tail test, it is 1.645. So there are two three values that you need to remember if you go to exam. Just 90-95%, that's it on one tail two tail. And otherwise, if any other value will be needed, then they will either provide the z table or they will either provide the values, like you need to use z at this, or let's say you have t table, use of t table, then and you have a t table use at 19 degree of freedom, so then they will provide like at 18, 19, 20. So then whatsoever is needed according to the question that you can use, so that must be provided. Okay, so this one will be the answer. If you have any doubt in any question I'm dealing with here, so then also you can tell me. And I have told the basic of it in the starting of the class, so that I will not repeat for the all the questions. So if you have any problem that how it is coming, then also you can ask, like how I'm dealing with the type 1 error or type 2 error, then I can explain it again. Okay. Okay. So the next question we have here is that a textile fiber manufacturer is investigating a new drapery yarn, which the company claims follows a normal distribution, having the mean thread of elongation. So there is a textile manufacturer company, and sorry. So the claim of the company is that mean thread elongation and standard deviation is zero point 0.5 centimeter, right? So mean is what? 12, and standard deviation is zero point 0.5, right? So the company wishes to test the hypothesis whether the mean is 12 against this using the random sample of 4 specimens. So n is equal to 4 here, right? And h naught is equal to 10, and h1 is mu is less than 12. So now what I have told earlier, that whenever you have mu less than 12 or mu greater than 12, then this means this is one-sided test, right? One side tail test or one tail test. So one tail test means greater than or less than, and if it is not equal to, that means it is two tail test. So here we are dealing with one tail test. N is equal to 4 mu, and this is given, and we need to find the type 1 error probability. So we need to find the probability of type 1 error, which is also denoted by alpha. So type 1 error. Type 1 error, I have told you here. Type 1 error is what? When we reject the null hypothesis even when it is true. Right? So probability of rejecting H naught when H naught is true. So H naught is true means given mu is equal to 12, we are uh, rejecting this null hypothesis. Now, one thing is given here is what? X bar is greater than, less than or equal to 111.5 is critical region. Critical region means what? If it is greater than 11.5, then it will reject, right? So it we will take what? Sorry, it will critical region means we are rejecting at that point. Remember us the sequence of for statistics subject that connected with it. For example, remember us means what? Like that connected to other. For example, probability and this, then sampling distribution. Well, then I have taken the class for these already, like probability and then random variable and then sampling distributions, and also this is the class for the hypothesis testing. So, what do you want me to tell? Do you want me to tell everything right now, or what? Like I'm not understanding your point. I'm so sorry. So you can just clarify in the message. So sorry. So critical region, we what we take here is that reject H naught. So when do we reject H naught? When X bar is less than 11.5, right? That means if thread is like less than 11.5, or maybe its mean is more less than 11.5, what will happen is that we will not consider it as uh, that the textile fiber manufacturer, this they will not consider it to go the thread like this in the market, because then its demand will be less, right? So X bar is less than 11.5. This is rejecting null hypothesis. And H naught is true. H naught is true means mu is equal to 12. Right. So now it is following the normal distribution. So what we do is that we will take a subject sequence in the statistic. Okay, that I have understood what you want to say, but then remember us means what? That I was asking. Like in my previous class I have given the informations about these things, right? So what does it mean by remember us? Okay, so it will be x bar minus mu, which is 12, and divided by the sigma, which is 0 point, right? So it will be remembering to us. Can you please write in it in, like, you know uh, line, whole sentence? Like, remember, you are already unmute. Can you just talk to me? Is it possible to you? Right. So uh, and then sigma divided by root n. So root, right. So it will be probability of z less than uh, this one will be zero point 0.5 divided by zero point 0.5, and root 4 will be 2. So it will be, sorry, this one was minus. So probability of z less than minus 2, right? Now again we can go to the z table, and minus 2, right? So minus 2, we can see here it is 0.0228. So it is 0.0228. So 0.0227 is given here, so this one will be the answer. I cannot do. Uh, you are already unmute I think you're not mute. You can see here. You are already unmute, but I don't know if there is any problem with your microphone. But remembering to us means what? Do I need to remind everything to you? What is sampling, distribution, and how do we sample and all? Because this is not in your course exactly. You have the course in that was in starting with what is random sampling and what is stratified sampling. So there can be different kind of samplings that you can use, and then on the basis of that, after doing the sampling, you can go through the hypothesis testing. But then according to the course that sir is conducting, I didn't find anything regardless of sampling to analysis of data kind of thing. Okay, because here this one is a base purely like theoretical. So whatsoever sir has taught in this course is purely theoretical. It is not practical, even though I have given some example related to the practical life also. But then it there was nothing like why like how do we collect the sample and all. So this is the part of theory. So uh, if you have still any question, then you can ask, right? Okay, so this one will be the answer. Okay, so next question we have here is that, yeah, yes, yeah, yeah. Hmm, hmm, yes. Oh, okay. So yeah, so basically we do with this because are you saying anything more? Should I answer it now? Okay, yes. Okay, so basically, I'm doing PhD in statistics. So, how we deal it with, I'm sorry, I didn't hear you. Okay, okay, okay. So what? Huh? Okay, so that the way I deal with this thing is that I'm so sorry. Your voice is so breaking that I just can't even understand what you are saying. So, from my side, all I can say is that you need to go through the probability and then probability distribution, random variable, all these things, and then this hypothesis testing. Because, like, if you have any kind of data, like I deal with the climate data, basically meteorological parameters. So, okay, so if I want to see any kind of future projections of the data, or if I want to see any trend analysis, I want to perform any kind of trend analysis, then I need to know. And then what we do is that, let's say I have the temperature data, and then I want to find the future projection. Then how do we do? So firstly, we make a hypothesis, okay, that whether our data is following any distribution or not, given distribution or not, okay, depending on whether our data is continuous or discrete. Now, to perform this hypothesis, we need to have the knowledge of normal gamma, So, firstly, when we have the data, first we need to know whether it is continuous or discrete. So that we need to know first. Then we need to know, like, you have the data, you can see it directly that it is some kind of normal distribution. Then you don't need to perform that time when you give a list of distribution. Then you need, if you have the previous knowledge of all the distribution, then how its density function looks, how its distribution function looks, how what are the parameters of it, then you can go through all these things. So now, since I know it is gamma distribution or exponential distribution, and this is fitting, then for the future prediction I can find the return period in which I need to find the inverse of that. So these are the things. That means basically, if you are performing the statistics part, if you are just dealing with the hypothesis part, then also you need to have the previous knowledge of all these things. So depending on work you are doing, it will be like what the previous knowledge you need to have. So that will basically depend on your work. So, and if you are like dealing with the uh, you're see, I'm just unable to hear you. So if you are saying anything, then let's just have a good network, or otherwise you can write it in the message, because there is just signal that you are saying something, but then your voice is not coming at all. Okay. So why is what why is what? Okay. Okay, okay, thank you. So if you have any other, do you have any other doubt? Yes. Okay. Okay, so basically this is the theory course. So if you want to have if you want to use this in research, I will recommend you can go through the courses in NPTEL only. There are data analysis course with Python or something like that. So basically, sir, or in R. So basically, they taught what you need. Okay, so then it will be more helpful to you, I would say, because they take the examples of the data, they take the examples, and then they say how do we do model regression, and there are a lot many things in statistics along with the distribution fitting. Okay, so there can be that will be more helpful to you if you will go through, and you will be able to learn one more language also. So that will be more useful to you. So you can just see data analytics, or with Python or R, or maybe you can just in NPTEL you can just search Python or R. You will find the data analytics course, and then you will see how do we, because there are much more things, right? There are modeling of the data, there is then analysis of the data, there is deep learning, there are a lot many courses. So this one is basically for the theory part. So if you want to know the whole theory of probability statistics, this one is good. Otherwise, it is not for you. Okay. Okay. So the next question we have for the probability. Okay, now if you do not have any question, you can mute yourself. Okay. So the next question we have here is that the probability density function of random variable x is fx is equal to 1 by lambda e to the power minus x upon lambda. So from here only you can see that this is the exponential distribution, right? So 1 upon lambda, so the parameter here is lambda. So the mean here will be lambda, the parameter is 1 upon lambda. So H naught null hypothesis is what? Lambda is equal to 3, and HA alternative hypothesis is lambda is equal to 5, right? So the test is given as reject H naught if x greater than or equal to 4.5, right? So we want to find the probability of type 1 error. So I really request you to go through the questions, because sometimes the type 1 error, type 2 error, and the power of the test, sometimes it's just so confusing that what are the region you need to use here. Okay, so this is what reject H naught when H naught is true. So reject H naught, that means this when H naught is true. So lambda is equal to 3. So x greater than or equal to 4.5 given lambda is equal to 3. Right? Now that we can find, so here we have the distribution 1 upon lambda e to the power minus x upon lambda. So 1 upon lambda e to the power minus x upon lambda dx, and it is from 4.5 to infinity, right? Because x ranges from greater than 0, that is given. So 0 to infinity, so 4.5 to infinity will be in the rejection region. So its value will be what? This e to the power minus x upon 3 divided by minus 1 upon 3 infinity 4.5, right? So this will be 1 by 3, 1 by 3 will be cancelled out. So it will be minus of e to the power minus infinity plus of e to the power minus 4.5 divided by 3. Right? So it will be e to the power 0.9, right? And then e to the power 0.9 is 2 point what? Minus 0.9. Sorry. E to the power minus 0.9 is 0.406. Oh, okay. No, this one was e to the power minus 1.5. This was 1.5. It's my mistake. It's 1.5. It will be 0.223. Now, power of the test. Power of the test, I have told you earlier. Reject H naught. Reject H, or maybe you can just directly write when we are rejecting H naught. So we are rejecting H naught when x greater than or equal to 4.5 given h1 is true, right? H naught is false means h1 is true, and for h1 is true, so h1 is true means this alternative hypothesis is true, so lambda is equal to 5. So if you have any kind of confusion, you need to ask, okay? Because this can be confusion. So here, yes, power of the test was okay. Meaning of the power means how much powerful your test is. You are testing this, na? this is, we say that a test is given as this, so we can test this. So what is the rejection this will, then if you have let's say whatever is the answer, if you have zero point 0.4, that means if your test is 40% powerful for the hypothesis you are testing for this particular distribution. Okay, so it will not be like if you have lambda is equal to 3 and lambda is equal to 5. So just basically we accept our test when its power is greater than, let's say, we actually we define whether what we need according to the our need, but then you of course take a test which is like very powerful. So here reject h naught if x greater than or equal to 4.5. So this is, and if you like you can see the answer, it's generally zero point 0.4, right? Anyone is true. So sorry, one of them is true, that we will see which one. So that means 40%. So 40% powerful test we generally do not take, right? So we will take the power which will be like 80% powerful or 90% powerful. So depending on your choice you can take the test. Okay, so now you can see. Yes. Huh. Hmm. Okay. Yeah. So basically, what you have is that firstly, you have one set of data. Let's say you have one array. Okay. And then firstly, you see whether your data is discrete points and then continuous point. Okay. Now, let's say you have continuous data. Okay. So what you do is that you fit the distributions, and then basically if you perform it in any software, then we see whether it is following the distribution or not following the distribution. So let's say I have this five set. Okay, I have, let's say this I am taking this whether my data will follow a t distribution or gamma distribution or beta distribution or normal distribution or name one more, let's say variable distribution. Okay, so let's say I'm just giving this, these are, or what we can do is that we can just say that get common distribution, means that will be according to the software that thing will change, but otherwise you can just take sorry, common distribution depends if you don't know the distribution of your data. If you know, then you can take get continuous or get discrete distribution, right? Now, once I know, so what can happen is that your data, let's say, following these three distribution, right? So because we are dealing with, right, we are dealing with some error, we are dealing with some 95% significance. That means we are accepting this 5% of error. So let's say your data is following this and this distribution, right? And of course they have their parameters. So what will happen is that we now perform this test, sorry, this, on the basis of this p value we see that which distribution fits our data the best. So and then we say that this is the best fit distribution, and then we can find the inverse of that. Okay, so firstly we see whether firstly we just fit, and then based on ks test I think we see, and then based on aic bic value, there are so many values. I don't remember exactly the full form of this, but then we go through this value. So firstly, we take the p value. Sorry. So p value, if it is, I think greater than 0.05, then we say it is following. Okay. If it is greater than 0.05, then we say it is significant, right? And significant means it follows this distribution. And let's say for three distributions, for gamma, beta, and normal, you got the p value as greater than this. So you are saying that the data follows these distribution. And to check the best fit, you can take it on the basis of AIC value. And yes, yeah. Now I just cannot go through all these details. You can just go through the details also, and I also don't remember the exact name. But on the basis of that, I think the AIC PIC value is higher for the data. That one will be the best. So then you can find what is the best fit distribution for your data. Is it okay? Okay, so I'm hoping it's okay. If not, then you can ask. Okay. Okay, so now this probability, we can see this is same as this. So in the place of here, we just need to change the lambda value. So it will be, sorry, e to the power minus 4.5 divided by 5. So it will be e to the power minus zero point 0.9, right? And e to the power minus zero point 0.9 was approximately, just checked, it is 0.407. So 0.223 and 0.407 will be the answer. So if you have options already, you can just tick once you get one, like type 1 error, you don't need to calculate the power of this test. Now, the next question given here is that the proportion of the adults living in Tempe, Arizona, who are college graduates, is estimated to be the p is equal to 0.04. That means there are 40% of the students are living, are college graduates in Arizona. Okay. So to test this hypothesis, what we have done is that, so firstly, we have this hypothesis, and then alternate hypothesis is what? P is not equal to zero point 0.4, right? And then we have taken the sample n is equal to 20, and we are saying that if the number of graduates is in between, let's say n, capital N, if it is in between 4 and 8 and n points are included, then hypothesis will be accepted, right? Then hypothesis will be accepted. So H naught uh, is accepted. Now we want to find the type 1 error probability, right? So probability of type 1 error. Foreign need are not included. No, here it is written, right? N points included. So it is in between 4.5 and n points are included. So that's why I'm writing 4 to 8, right? So type 1 error is what? It is reject H naught when H naught is true, right? So reject H naught when H naught is true means what? We are rejecting this. So when do we reject this? We are saying we will accept H naught if X is in if N is in between 4 to 8. So when do we reject? Either n less than 4, given h naught is true means p is equal to zero point 0.4, plus we will reject it if n greater than 8. Then also we will reject it, right? Okay. So uh, now you can see that it is what it is again, this binomial distribution, right? So it is n is what, 20, and this one is p is what. So you can now find this one and this one. So it will be what, this is 4. So let's say p minus p1. So basically you will have p minus p1. So either you can do either in the opposite form, means you can just deal with 4, or you can deal with point 2, point 4, sorry. So then what will happen, it will be 4 by 50, sorry, 4 by 20, because n given here is what, 4 by 20, right? So it will be this p minus p1 divided by, let's just find what is this. So it is point 2 minus point 4. So it is point 4, right? So 4 by 20 divided by q1. Sorry. So it will be, I think, uh, 20, 40, sorry, 2 by 4. So it will be point 0.2 minus point 0.4 divided by under root p1 is what, p is 4, and then q is 6, and then this n is 20, I think, right? So it will be 0.2 divided. So I'm writing this for the left one, right? When it is less than 4. So this one will be zero point 0.2, and then divided by, let's say, 4, 6, 4, 500, 6 by 500. So then we can use the calculator here. Let's just use. So it is 0 0.2 divided by under root 6 divided by 500. So it is 1.82. And it was negative. So this one will be negative, right? So this one we have found. And the next one, n greater than 8. So it was 8 by 20 minus zero point 0.4 divided by zero point 0.4, zero point 6 divided by 20. So this one, I think, zero point 0.4 minus zero point 0.4. So this one will be 0, right? So for the left one, we have found this value. Uh, so probability of, because we are just standardized, we have just standardized it. So z is less than minus 1.8. What was it? 82, sorry. And then plus z greater than 0. So then we need to go through the step table, and 1.82. 1.82 is 0.0344. Is z greater than 0? So 0, it's 0.5. Right? So it will be 0.5344. So this one is the closest one. So this one. Okay, binomial. Yeah, because see, you have N, P, and Q, so you can take it as binomial distribution, and then you can do the sorry, you can just by using yeah, scientific calculator will be provided in the screen only. So if you go through the exam details, that is already given, I think. So here you can go through your exam details and then exam format. Exam format is here, and this is, yeah, on screen calculator demo. So this kind of calculator you will be given, so you can do the calculation here. Okay. So the next question we have here is that x be a single operation from this population. So again we can see that this is what, this is this is the exponential distribution, we can see. Now null hypothesis here is this, and alternate hypothesis here is this, right? So again we need to find the type 1 error and the power of the test. So probability type 1 error, I'm so sorry for the disturbance, will be probability of x greater than 1 given theta is equal to 1. Now, before I found this and I do the calculation, I just want you to write what is the probability of power of test. Like I have gone through so many questions here. So what is the probability? Like what is x and given what is theta? What will be this power of the test? So I am giving you 2 minutes for that. So think how I have solved the questions till now, and then tell me. Otherwise, I'll tell you what will be the answer. So this is h, and this is k. Then how do we find the power of the test? I have written already the type 1 error. So power of the test. You can write your answer here in message. I'll see that. A. A, you have solved the answer already? Okay, then I need to check. Okay, it's not A. And I was not asking about the answer of this question. I was just asking how do we write power of the test in the term of this probability. So what will be here and what will be here? Like you can write which theta value we should take, theta 1 or 2, or x is greater than 1 or x is greater less than 1. So which what do you think we will have this here? Okay, so I'm gonna tell you the answer. You can check whether your answer was correct or not. So power of the test is what? Reject this h naught when h1 is true. So h1 is true means theta is equal to 2. Now we can solve the 1 and then just theta is equal to 1. We can put theta is equal to 2. So uh, solving type 1 error, or you can say alpha, is equal to what? Probability x greater than 1 when theta is 1. Right? So 1 to infinity, theta is 1, e to the power minus x dx. Right? So it will be e to the power minus 1. Right? 1 upon e, and then probability. And then power of the test will be, the test will be uh, 1 to infinity, again same, and theta is 2 e to the power x upon 2 dx. So it will be 2 e to the power minus x upon 2 divided by minus 2. Infinity 1, in the time of infinity it will be 0, and in the time of 1 it will be 1 by e square, e to the power minus 2. So 1 by e and 1 by e square will be the answer, right? If you have any confusion, you can ask. Okay, so can you explain the concept of type 1 error and type 2 error in the concept and context of hypothesis testing and their relationship? Yeah, so that I have covered already. If you go through this class, you will understand. Because see the class started from 6 set 6:10 actually, because I have waited 10 minutes, so I have already explained what is the relationship. So in this you can see the note I have given here, right? So what is null hypothesis, what is alternative hypothesis, what is one tail test, two tail test, what is significance level, why significance level is important for us, and then what is simple hypothesis, what is composite hypothesis, and then what is critical region, acceptance region, and then error, why do we need this error, and that's all. Okay, and relation is uh, relation is this: power of the test is 1 minus beta. So if you have type 2 error, so as I have said, what we want to do generally, we want to reduce this type 1 and type 2 error, right? So then uh, when type 2 error will be when error will be very less, our test will be stronger. So here you can just understand that our null hypothesis was true. Actually, that means our, let's say, a data, let's say we are saying that it has increasing trend, and it was increasing trend, but we have said that it is false, that it is either constant trend or no trend. That means, or either, let's say, it is decreasing trend, so we have given the wrong conclusion, right? So it comes under type 2 error. And type 1 error is when you reject h naught when it is true, right? So these are basically, this is the error. And much more as I have told earlier. And still, if you have doubt, you can either ask in next class, or there are so many information available in the Google that you can make use of. Okay. So the next question here is this, and then we will, like, there are some question left that we can do in the next class, because it will need much more knowledge of stats. And then these are quite long. If so, this one will be the last question for today's class. So the given thing is there. Given question is: a manufacturer is interested in the output voltage of a power supply used in a PC, right? And output voltage is assumed to be distribute normally distributed with a standard deviation 0.2 volt. So sigma given here is zero point 0.2 volt. H naught is mu is equal to 5, and H1 given here is using n is equal to 8 units. So n is the sample size. Now if acceptance region is this, so acceptance region is 4.85 x bar 5.15, right? Then find the power of the test for detecting a true mean output voltage of 5.1 volts, right? So power of the test, we use null hypothesis mu. So mu will be used as 5.1, not 5. Okay, in as 5, mu is equal to 5.1, and then the power of the test is what? Sorry, reject H naught when H1 is true. So power of the test, you can even see from here: reject H naught. Reject H naught means what? Accepting H1. So we are accepting H1 which when H1 is true. So this is power, like if its probability is greater, then it will be more powerful. So when do we reject? When x is less than 4.85 or x is greater than 5.15, right? So we will x minus mu divided by sigma divided by root n, and then greater than 4.85 minus 5.1 divided by 0.2 root 8 and then plus, and then I'm writing this as z directly. So 5.15 minus 5.1, right, divided by 0.2 and then divided by further root 8, right? Okay, so now you need to calculate this. So this one will be z greater than, sorry, z greater than 4.85 minus 0.2 divided, sorry, minus 5.1 divided by 0.2 and then further divided by root. So it is minus 3.53 plus probability z less than 5.15, right? So it is 0.707. So table. Now z is greater than this means 1 minus 3.53. So 3.5.004 and then z is less than 0.07. So 0.07, sorry, 0.07, 0.707, so 0.70, so it is point 0.2420. So it will be 0.2420. So I'm sorry, I'm just a little bit confused. I think I'm gonna use the positive table here. Give, so it is not given. So basically z less than 0.707. So it will come by this side at 0. It is 0.5. So if it is greater than 0, it is 0.5. So if it is less than this, it must be 0.2420 plus 0.5, and this one will be 0.004. So ultimate answer will be 0.5, 0.746, something like that. Okay. So this is not given. Yeah, I must have done something. Just a minute. So 0.70. What was that? Okay. Okay, sorry. So this will not come. So it will be 0.244. So it will be 0.244. So it is this, around this, because we are not taking this 0.707 in the table. We are just dealing with this. So this one will be the answer of power of test. Or otherwise, what you can do is that you can take power of the test as 1 minus beta, and then you can take like this region given h1 is true. Okay. So this is all for today's class, and then we will continue some questions from today's class in the next class and then the next topic. So that's all for today. Thank you for the joining. And okay, I'm gonna cut the call. So if you have any questions, you can ask now. Otherwise, I'm ending this class. Okay then. Bye bye.